So all elements appear exactly twice, except for one. One appears once. What other things do we know?
The array won't be empty.
Array won't be empty. Okay, cool. Anything else? Okay, sounds good. What are some approaches that people tried?
Eric used a dictionary to keep track of the frequency of numbers.
Cool. Keep track of numbers, and then do what?
He then looked for the key, which is the integer that had a frequency of 1, and returned that key.
Int that has fric 1, return that key. Cool. What else did other people try?
Jocelyn and myself tried something similar, but before we added a key into the dictionary, we checked to see if it existed with a value of 1, and if it did, we removed it from the dictionary. And so that in the end, the dictionary would only have 1 value in it, and we wouldn't need to then loop through and look at all the values again.
Okay. So add key to the dictionary. If there was no value for it, remove the value. How do you remove the value from a dictionary?
We were trying, we didn't get this to work entirely, but we were looking at something like dict.remove value for key of whatever we were going through, which removes the key and the value as far as I could tell.
Cool. Did you end up finding a function like that, or maybe there's a different way to do it?
Just dot remove value.
Okay. Let's say the value there was 1. Do you want the value to be 0, or do you want it to be something else?
I want it to not be there at all.
Yep. To not be there at all, which would mean you want it to be what?
Essentially gone, nil, nothing.
Yep. So to remove a key, you can set it to nil.
So does dot remove value for key remove the key as well, or?
Let key equal int dot remove value for key. Yep, that works.
Okay.
Value for key. Function also helps. Okay. What other approaches might we have tried? And here's a hint. Did the frequency of the, let's think of it this way. How many different values for the frequency should we have expected? How many possible values could a dictionary have held? Eric, you say 2. Can you tell me what those are?
One and two.
Yep. Any key. The frequency would be 2 or 1 for any key. And which of those is the answer? Which frequency would tell us that that's our answer? Yep. We're looking for 1. So something else that we know is once the frequency is greater than 1, just like Ian and Jocelyn said, we can discard it. This question specifically says the frequency is 2 for one reason. Does anyone know what that reason is? The hint is it's an even number.
What was the question, David?
So the question is, or kind of the statement is, the frequencies can be 2 or 1. We are looking for the 1. There's a reason this question has the ones that we can exclude be 2, or more generally, it could have been an even number for a different kind of approach. There's a reason that we discard the ones that have a frequency of 2 rather than just saying, find the frequency of 1, everything else has some other frequency. It lets us do one specific thing because the frequency is 2 for the non-answers. Another hint might be, in that dictionary, instead of keeping 1 or 2, we could have kept true or nil. We could have said, if I saw the key was in there and it was true, well, I could just turn it off. I wouldn't even have to check for 1. Any old value held in that dictionary, if I found it, I would know it's done. So that means that we could have done something like use a set. And we could have said, if something isn't in the set, add it. If something is in the set, remove it. Think of it like turning a switch on or off. So the reason that this specific instruction that every element appears twice except for 1 is important is because with an even number, we could say it's on or off. We could say it's true or false. We don't actually care about the count. We just care about potentially seeing it before. And with an even number of elements for every incorrect element, we can just say, okay, I saw it, get rid of it. It's gone to me now. And then if that's the case, in our set solution, how do we know what the answer is? Yep. So feel free to use spoken words for anyone using the chat. It's great to not hear my voice. I think everyone would agree.
whatever's left.
Yep. So with this approach and with the specific logic of turning a switch on and off, only one thing will be in the set by the end of the problem. And by the way, what we didn't talk about is that with all these approaches, we'll probably just have a for loop iterating through, right? Cool. So Rod, can you help me make my set solution?
Sure.
I'm gonna call it func single number, and it's gonna take in one of these arrays. So, yep. Let's let input one name for this thing, and let's let input two name for this thing. I'm just going to make some quick asserts down here. Assert single number for what type of argument does this single number take in?
An array of int.
That's right. So it's an array of ints. And then, Jocelyn, what does this return?
Say that one more time.
What's our function going to return?
An int.
Yes, ma'am. Going to return an int. So single number, and I really love being lazy with these interview questions and not even naming my arguments. For input one, let's do this in Swift. Cool. So for the first one, for the first input, the result of this function should be 1. And then for the second input, the result of this function should be 4. Let's do it with a set. Rod, are you ready?
Yes.
Cool.
Okay. So you're gonna want to make an empty set. Let's set, yeah.
Right. Is this good so far?
Yes, I think.
All right. Cool.
No, it's not.
Oh.
You have to, it's a constant. You have to make it a variable.
Oh, okay. Thank you.
Okay. So then you would loop through the array.
Cool. I and R.
If the set does not contain I,
Mm-hmm.
put I into the set.
Okay. I don't think that's syntactically Swift.
Set dot append, does that work?
Let's see. Set dot append. Maybe there's something similar to it.
Insert.
Cool. All right. Set dot insert.
I.
Sweet.
Okay.
Let's
So-
pass this off to Kevin. Thank you, Rod.
No problem.
Kevin, are you there?
Yes.
Hi, Kevin.
Hello.
Get it, Kevin.
First.
So if our set doesn't contain that thing we added, what was the other situation?
If it does contain, we want to remove it.
Cool. So else.
I forgot the subscript. Set dot. Remove or whatever it might be. Is it removed?
Sounds good to me.
Remove member I.
Cool. So we will remove member I. Sounds good so far. Is that all we have to do in this loop?
I believe so.
Cool. And then what do we do at the end?
We just return whatever is left in the set. So return set dot first. Able to do that? Yeah, set dot first, and we could bang since it'll definitely be there.
Okay. Set dot first. Let's see. I don't remember how these asserts work.
It checks if the what the function returns is equal to what you've asserted. So if it returns 1, then it'll assert true.
Cool. And it'll break if this condition is actually false. So our assertion failed on line 47. Dang. All right. That looks great. Can anyone do lines 34 through 43 in one line? We could probably do it with the set, but we could definitely talk briefly about an XOR, which I don't think. Try it with 2 lines to start. Let's put this into 1 line.
Can we use a ternary?
We could definitely use a ternary. So set dot contains I question mark set dot insert I colon set dot remove I. Cool. That's nice. I like that. I'm actually going to put that down here. Put that out. Set dot remove I. Oh, why can't I do this? Let's take a look at this function again. Look at this guy. So let's look at remove. I'd love if you could just give me the documentation. No. Maybe my Xcode is being a jerk. Yeah, but Sunny, can you talk us through what you're thinking?
The function remove for a set returns an optional integer. So there's a return type there that maybe this doesn't know what to do with, because for insert, that doesn't return anything. And so the two functions have a different return type. Like one is returning void and the other is returning an optional int.
Yep. I don't even know a hacky way we could get around this. Let's try this. Isn't that awful? So these two functions return different types. And typically in a ternary, it needs the same return type. And I just told the compiler, actually, I don't care about the return type with this underscore, but if you really need me to account for the return type, it can be any. Do we hate or love that?
It's okay.
It's okay. Okay. Cool. So that works. Then real quickly, how could we do that without a for loop? How can we iterate over any array without actually using a quote unquote loop? Could use a closure. So can I just do this? Or should I call a different function? We can use a higher order function on our array. And here are some options. Map, reduce, filter, or for each. Which of these do you think we should use?
Reduced.
Who wants to use reduce?
Hmm?
Who said reduce?
Eric.
Albert, why would you use reduce?
Because wouldn't we be doing this until we get only one element?
Yeah, we do want to do that. What is reduce for?
Reduced, I don't know.
So reduce is where you want to perform some operations on each element, while also keeping track of some total. Actually, generic intermediate result. So if we wanted to add everything up, we could use reduce. We could probably figure out a way to do it with this problem, but there's probably an easier one as well. Eric M., what would you use?
For each,
For each? Yeah, what does that do?
it goes to each item and does something to it.
Goes through each item and does something to it. Let's be specific there. Does it actually change the array?
No.
No. So it doesn't change the array. How is it different than a map?
A map changes the array.
So a map also doesn't change the array, but a map does something different. Let's look at this. What's the return type of for each? Right there. Nemo, what's the return type of our for each function? You see it on the screen?
Gross void? Void?
Yep, it's a void function. Whereas a map returns us an array of those things changed in some way. You can return any type, but map returns an array for each allows us to do something. Cool. I love our higher order array functions. Amazing. So if you want to keep refactoring, see if you can use for each on the array. One last approach, and I promise set single number with set solution. Promise we will not worry about how this works right now. In the employment intensive, we will in a little bit. Single number manipulating bits. And because this array is an array of ints, because we just want back an int, this is a solution using exclusive or the XOR operator. What? Well, all we do is loop through I in 0 ... r minus 1. Sorry, r dot count. You don't need the minus 1 because there's a less than sign. Ready for some magic? Result XOR that number, then you just return the result. Sorry, copying my own code from somewhere else. What does this do? Look it up, I'll tell you. No, what this does is it manipulates how that number is actually saved. Wait, Kevin, what's a nani? Like nanny? What in Japanese? Got it. Okay. What this does is it manipulates how this int result is saved. So like what its values are. And to spend time on it right now would not be that awesome. But why do I show you? To show that you can solve this question in a variety of ways, including ways that you might not know. And back with the more Swifty solution, if I'm just iterating through and I'm looking at each element, which is effectively what I'm doing here, or anything in the array, manipulate it using that value. So it's not really too much about what this XOR is actually doing, but here's another solution. Amazing.